Hello everyone, welcome back to the Digu Science channel. This channel presents educational videos, specifically on physics and chemistry. In the previous series, we introduced the concept of induced EMF and Faraday's law. In this series, we'll likely continue discussing that topic. We'll start by considering a conducting loop. Let's assume this loop is in the XY plane. Above the loop, specifically on the positive z-axis, is the north pole of a magnet. Below the loop, or on the negative z-axis, is the south pole of a magnet. We know that the direction of magnetic induction is from the north pole to the south pole. The direction of these magnetic field lines is in the XY plane. We can write these magnetic field lines as cross lines. This loop forms a closed loop. A closed loop exists in an area with a magnetic field. As the number of magnetic field lines penetrating the closed loop increases, based on Lenz's law, an induced magnetic field will form. Its direction is toward the positive z-axis. To produce this induced magnetic field, an induced electric current will flow in the conducting loop. The direction is counterclockwise, as shown in the figure. Electric current flows due to a voltage difference. This voltage difference can be calculated using Faraday's law. Let's simply write epsilon equals minus n d phi dt. In simple terms, an induced EMF voltage will appear when there is a change in magnetic flux. However, magnetic flux itself consists of three quantities, B, A, and cosine beta. In this case, the surface area of the circle is constant. Likewise, the angle between the magnetic field and the normal to the circular area is constant. We can exclude the factors A and cosine beta from the calculation of d dt. This dB dt represents the rate of change of magnetic induction over time. Conversely, when the number of magnetic field lines penetrating the surface of the loop decreases, based on Lenz's law, an induced magnetic field will form, directed toward the negative z-axis. To produce this induced magnetic field, an induced electric current will flow in the conducting loop. Its direction is counterclockwise, as shown in the figure. Hopefully, this tutorial provides an overview of the induced EMF voltage triggered by changing magnetic fields. And don't forget to watch the next video.